everyone. Welcome to the presentation from Silos to Swiss Army Knives. I'm Likith Upara, a data analyst with Ed Plus Action Lab. I work with a very specific piece within ASU Online Partnerships called Academic Partnerships. These partnerships allow students from other universities and institutions to enroll in courses offered at ASU because those courses are not offered or programs are not supported by their institutions. I build workflows in architecture that ensures these students' experiences are seamless. I know that the title looks like it's ChatGPT generated because it is, and in a quick couple of minutes, I will explain why. As a data analyst fresh out of grad school, I was expecting more of a routine, but a couple of months into it, I was doing all sorts of things. I was building ETL pipelines, doing some data architecture design. Just for a timeline perspective, I built my first dashboard after I did a Git push to our data uh, architecture. So this made me ask myself, your role has changed so much over time and so much, what's the next iteration in this change? And when ET asked to pitch the presentation ideas, I just wanted to try for fun, and I put this abstract thought I had in my mind into ChatGPT and say, create a presentation name, create a brief description, and I pitched that idea, and it was, to my surprise, accepted, and that made me realize, okay, that is a sentiment that a lot of people have. A lot of people want to prepare for what this next iteration is going to be. How do we tackle that change? How do we prepare for that? I wanted to address this in front of a wider audience and maybe start a dialogue between data professionals at ASU and see where that leads us. I took a twofold strategy to address this question and prepare for this presentation. I've reviewed some of the peer-reviewed research publications based on data professionals' experience and insights, and I've conducted some interviews with data leaders at ASU. These are the folks that drive the culture of the ecosystem and help onboard newer tools and systems. Let's take a brief look at what the data rules and their evolution look like. In the early data ages, we're talking about data center engineers building up data clusters using hard drives and on-premises architecture. Data was cleaned by a different team, analyzed by a different team, and statistical computing by data scientists was done by a completely different team altogether. Teams were very, very siloed, and this was an era that led to the development of distributed databases that are built off of hard drives and hard disks. This leads us to the age of unicorns. Due to the rise of distributed processing and distributed processing frameworks like Hadoop and MapReduce, these frameworks allowed us to mine big data and led to the emergence of software as service tools like Tableau, Analytics, and Salesforce. These were very, very computer science driven approaches, and because there were so many variety of tools that allowed users to do so many things, there was an expectation that a data science hire should be able to juggle all of these priorities and be able to do a lot of these things. Somebody who is so good at all of these skills was so rare to find, you could call them a unicorn, and a data research presentation actually called them data unicorns, and hence I call them the age of unicorns. And this is a very, very interesting use case because somebody who's good at a lot of these skills is at some point going to focus on very niche areas and focus on 2 to 3 skills, which will lead them to have a generic level expertise on other skills that might be very critical to the organization and the team. And that made teams understand, okay, we need to find better ways to break down these roles and address the business use cases that we have so that we're servicing all of our needs in a clear manner. And that is the age of anchor roles. In a cloud-based world, there is a space for everybody to focus on their specific use case because the hardware is abstracted by infrastructure as service tools like cloud services provided by AWS, GCP. And because of this, we have a space right now for data engineers to build robust and well-planned data architectures. And architectural excellence allows analysts such as myself to focus on business problems that will be solved by meeting the stakeholders where they're at. And data scientists now can focus on data computing and statistical analysis than data wrangling and addressing the issues within the data and understanding where the data came from. Now, what is the future? Are we going to focus more on AI? Or are we going to focus on data infrastructure maturity? Or are we going to focus on context and metadata? To understand that, let's take a deeper look at why the data stack evolved the way it did and how it evolved. How has the data stack evolved? Starting at the early data ages, we had hardware on-premises infrastructure. It lacked support for big data and could not keep up with the growing data needs. Distributed processing, which came after the hardware on-premises infrastructure, made it work with big data handling and it led a hand to the growth of software tools. And these software tools allowed for a variety of ways to clean, extract, store, manage, analyze, and report these data. These, although these tools allowed so many things in so many niches, these could not keep up with the increased demand for fresh data and data accuracy. And this is what prompted us to move more towards a cloud development and adoption mindset. Here we have opportunities where we can do real-time analytics on streaming data, and infrastructure for us is already set up via service providers. Primary examples for in this use case are the BI desktops we use. These are pretty much servers and infrastructures that are set up somewhere in a data center, and we can access them remotely and conduct massive loads of data operations locally and not be impacted by outages within our local systems. Now that we got to a comfortable place where we can work with near real-time data, we understand that we're missing context and metadata. One of my interviewees addressed that there are over 50,000 data assets that are not documented within ASU. And that's the level of metadata and context that we're lacking and we need to build towards. We need to drive towards systems, and we are driving towards systems where we are trying to embed metadata within the data itself. Upcoming technologies like DBT semantic layer and MCP, model context protocol, and emphasis organizations like AWS and DBT are putting on metadata and context speak to the importance of context and metadata in a world where we're going to work with AI. Now let's take a quick look at why the data stack has evolved the way it did. The three proponents of the data stack evolution are organizational needs, organizational culture, and the scale of expanding data. How does the organization want to spend its resources and grow? What are its priorities? An organization like ASU wants to know what makes a student want to apply to ASU, what makes them want to enroll in a course and not drop it, or what makes them want to go through with the course even though they are lacking grades or resources that they need. We want to understand that so that we can make their experience better and lead to higher graduation rates, higher enrollment rates, and lead to a program success. Now, the cultural changes. What do the leaders want their teams to spend time on? Do they want them to spend time on research? Do they want to spend their team's resources on fighting fires on a daily basis, which most of us are doing quite often? Two of the data leaders from different teams have reported that stakeholders are expressing more interest in insights rather than learning to use dashboards. They want just that metric that supports their hypothesis. They want just that number that will go on their slideshow, that presentation, rather than, okay, how does this dashboard work? What does this dashboard mean? And how has it changed across different programs? With evolving sentiments like this and evolving technologies, how do we address them? How do we move forward? The response to these questions and concerns is also a critical reason behind how the tech stack has evolved. Now, looking at the scale of expanding data, based on a Google search just now, I found that there are 402 million terabytes of data created each day. A way to look at this would be the data is expanding at the scale it is due to the interest of stakeholders who want to mine it, use it, and improve their processes using that data. Near real-time processing is available even within ASU's ecosystems, and any relevant data Within the context of ACE, you can be mind curated and analyzed to support various teams and various programs in schools that are not supported uh, currently. What is the next state in this evolution? What are the tools of tomorrow? What are the roles of tomorrow? Any guesses? Okay. Uh, is it AI? Is it what's going to drive this change? What's going to drive the next state in evolution? Is it the tools? Is it the roles? Is it the business requirements? Or is it the industry culture? Is it something completely different? All of these areas cannot be addressed without impacting the others. These are so tightly knit together, we have to find ways to address and service them simultaneously. And one thing to remember is no matter what drives the change, your individual skills are going to help you ride the wave successfully. Now, this is a question most of us have asked ourselves at some point, or probably will ask in the very near future. Will AI replace me? The short answer is no. Uh, we do not have enough context, as I've just established, and we have incomplete semantic layers, and a lot of the data infrastructure models are very, very incomplete. And AI is a black box. We don't know what input causes it to respond in what specific ways. We know that giving it context, we know that training it with context will allow it to build better responses and better informed outputs, but do we exactly know what's causing that specific response? Can we predict that response each time? Um, One specific use case that comes to my mind is a couple of months ago, I read this article where a company integrated an AI tool completely with their database, and a 2 a.m. job failed, table creation failed, and the AI tool dropped the entire database because it thought that is an error that could creep across the database, and the only way to prevent that from happening is drop the entire production database altogether. These are the risks that exist in real time with integrating AI without systems, without a lot of thoughtful planning behind it. There are many, many reasons, and their proportions at any level could impact in creating data slop. Incorrect data, irregular data, and data that could potentially cause many, many liabilities for an organization like ASU. One thing we want to remember is the benefit many companies may see from AI in their data will not outweigh the potential cost of losing all their data or reporting data slop altogether. One thing to know is AI is not the end itself, it's just a part of the journey. And with that being said, we do need to acknowledge that AI can do a lot, and we as data professionals can do a lot too. Putting together what we can do can be exponential. Given enough understanding, practice, and training you would need with any other tool, putting that energy with AI is also going to help us become better data professionals. How do some of our data leaders look at AI tools in our ecosystem? They definitely see AI being a part of our toolkit. AI is here. Many teams have already been building their own bots, their own knowledge bases. And I personally have a bot I call Batu, which tracks some of my programmatic data. It can still be tuned to work better. Every once in a while, I see it hallucinating. And then I find ways to address that. And now I find that there's a completely new hallucination that's out there, need to address. It's a part of the practice and training that we need to do to understand how do I prompt better, how do I give context better for the AI tool to support me and make my life easier. Another way leaders look at AI is they are our partners in programming. They are thought partners and mini me's that will help us in becoming better solution engineers and data architects and produce data products beyond the regular reports and dashboards that we produce on a daily basis. Right now, I don't know if this was already presented, but I know that Mike Sharkey has a NLP model that he's working on where you put in a prompt, ask a specific question, it gives you very, very accurate data within that limited context. So the tools are here. It's just how do we use them better? How do we train them better? How do we train ourselves to use them better? That's the context. So AI will not replace you, but somebody who knows AI will definitely replace you if you're not keeping up. Now, How do we coexist with AI? We all need to understand the following. There isn't enough context to make AI models successful 100% of the time. And we need to build our context and metadata to help them help us. And AI is shapeless. It can take multiple personas supporting a multitude of tasks within every ecosystem that we embed them in. Okay, quick show of hands. How many of you put your personal information in ChatGPT or another AI tool previously? That's good. Oh, you should not be doing that. That was a test and you failed. Uh, it, we should not be putting in our personal information within any AI tool for the reason that we don't know how and where it will surface on the other end and how it will be used in mind. Governance within AI and with AI is a piece that we need to understand and codify to maintain and uphold data ethics, privacy, and security concerns within each organization. In 1979, IBM put out a training manual in which it called out, a computer cannot be held responsible for its actions and hence should not be given responsibility. At the end of the day, AI is a computer and you should not be giving it access. Organizations should focus on human-centric processes as opposed to human-in-the-loop processes. To close this section out, one thing I agree with our data leaders is we all need to become some level of prompt engineers or figure out how to leverage AI within our specialities while still being the specialists ourselves. Now, believe it or not, there's a world beyond AI. There are concerns that we need to address, like the data maturity models. How do we as a team upskill ourselves, upskill our technology, and solve problems that are new rather than solving problems that we've already identified and solved every once in a while. Now, there are many, many teams within ASU that are suffering due to data silos. We need to find a way to service them and empower them with the knowledge and information they need to be successful like every other team is. Now, we have another concern that we want to address is what are the tools that we're using? There is a concern of vendor lock-in with proprietary tools. On the other hand, if we want to completely shift towards open source tools, they have maintenance issues. We don't know who's maintaining it and what will happen if one day they just decided to not update them or provide enough support. And then we have a very, very high concern of data freshness and accuracy. What is the data we're reporting and how fresh is it? And increasing and evolving stakeholder requirements like, oh, we don't want a dashboard, we want a metric, we want a story, we want the narrative. Is it growing? Is it depleting? What is going on? That is another stakeholder requirement that we need to understand and track. The major concerns of our data leaders can be summarized with this question here, which is, how do we become a data democratic and interoperable system within ASU? How do we address the underserved teams that are suffering due to silos? And how do we help teams spend more time developing and solving newer problems instead of fighting fires they've already fought? And here are some of their outlooks on the ecosystem that we have. They all agree that a good data professional should have at least a base level understanding of what their counterparts are doing and understand how the data that they work with comes there and how the data is going to be used once it is out of their hands. The architecture that we own and maintain should need to reach a point where we're not firefighting. Oh, I'm repeating myself there. AI and LLM agents will be a part of our data toolkit, and how do we work with them while still maintaining that human touch and not losing the human-centric processes that we have in place? How do we make data reporting stable and easier to self-serve? We have all seen messages in channels Alteryx, Tableau, and BI Desktop and Ask Analytics asking, oh, this dashboard is down. Oh, this tool is not functioning as I'm expecting it to. How do we resolve these issues and go beyond that? How do we spend our time building products that are more strong and are not susceptible to failures for the most part? We're reaching the end of the presentation here, and here are some potential data roles of the future based on the conversations I've had. Uh, Earlier, I mentioned data unicorns, which are data professionals who can juggle everything, who can do everything. Are we going back to unicorn mindset? No. But the boundaries within our data roles that exist today are going to become thinner and create a space for newer niche roles. The ecosystem will not change so much that we have to start from scratch, but we would be pivoting slowly towards these niche roles and allow our teams to fill in the gaps that we're suffering with currently. Some of the roles, these roles in some shape or form exist today under different names, but this classification is an attempt to give them better titles, brief definitions, and introduce them to the data world, which will be driven more and more by AI in the near future. The data product developers are personnel who will move data objects and create data objects in a way that it will empower their business users with self-serve tools in a easily ingestible fashion. These users meet business stakeholders where they're at. Instead of training our data users, we are going to build products that will support data users, data end users, and our business stakeholders. Now, data solutions architect. This is a role that currently exists, but we will see more analysts and engineers move slowly towards that role. And these architects will help and build our systems that empower and enrich the work that data product developers and data reporters will do. Data reporters will work on building actionable narratives, not just a single KPI report, but a story that will support the entire ecosystem, the story that is filled with context. Now, data context developers. Context is documentation's cooler, popular cousin. Uh, as I've called out already, there are many, many assets within ASU that need metadata and context. I believe that we'll have data context developers who will identify the documentation in a holistic manner, sort of understand the lineage. Why is this data asset existing? What purpose does it serve? How is it built? And how does it need to be changed? How do we find ways to improve this and build it in a much stronger fashion? AI developers, these are developers who understand the business context and train the models and maintain them for wider usage. For example, the natural language querying tools that are out there for identifying and defining data objects. There is an actual natural language querying model that is out there where you can give it a table name, a table within data warehouse, and it'll give you the fields within it and brief definitions. Uh, Now, how do we prepare for this future? Here's what I would like for all of you to take away from this presentation. Tool agnostic basics, critical curiosity, constant learning, and collaborative strategies are the must-haves that will help you tackle any change that will come along in the future and will help you come out on the top, whether if the change is driven by AI or not AI. Tool-based agnostics, these basics, fundamentals will help you understand and pick up newer tools in an easier way and gauge how these tools support you rather than replace you. Critical curiosity, I feel that the urge to fall in a rabbit hole to understand something better is something each data professional should have. Not just for the future, but even today, it makes us better at what we do. Constant learning. This is an advice that is not new, but it never gets old. Understanding and taming new technology is a must in a constantly evolving ecosystem. Collaborative strategies. If you didn't already know, we're all in a collaborative field. The products we generate are most often used by someone else, and the objects we use are also used by someone else's influence. Unless you're Josh Johnson, who builds products from scratch. Uh, Ability to critically assess and effectively communicate with your partners and understand what they need is going to help you go ahead in career and stay afloat, even with AI in the loop. What are some of our data leaders interested in learning? This is a question I asked them, which had very little influence with all of the interview questions I had previously. Uh, Summarized, they want to understand AI better. They want to understand the ethical concerns involving evolving ecosystems such as ours, maintaining the human connection within teams as they grow and change with AI in the picture. and understanding newer technologies and what newer grads are learning, and strengthening fundamental understanding of their data basics and the technology basics that they work with. Quickly to name some of those, I know that they might not all be visible because of the lighting. Critical thinking, effective communication, contextual nature of technology, and learning and understanding what the new grads are learning, and ethical implications of what we do with AI and the regulatory considerations around data and near real-time data processing, CI/CD development, open infrastructure. These are some of the skills they want to learn, understand, so that they can support their teams better. These are the colleagues that have helped make this presentation possible, and I just want to take a quick moment to call them out. Um, and here are some quotes you can look at from our data leaders while I answer any questions.